Thanks, Colin. It's a pleasure to be here and to talk to you about water. I'm not an economist or a social scientist, but certainly they're very important in this whole issue of water. And I really will not weigh in on whether water is a public good or a private good, but maybe we can have good questions and discussion about that. But I thought I'd tell you a little bit about water with respect to more of the science that informs the policy of water, and that includes things that are affecting our water supplies and our water resource very much right now. And that includes climate change, water quality issues, groundwater quantity, I'll stress more tonight, energy choices, and time permitting, we'll talk a little bit about biofuels. And finally, water is our most precious human resource from the standpoint of global Millennium Development Goals that we're far short on water resources for people, especially impoverished people, and for good sanitation, and even maybe water for irrigated agriculture and under. First, with respect to climate change, you know, we have about 100 years or so of pretty good data in this country on our water resources in past decades, and especially on precipitation and runoff from that precipitation at airports more recently. Before that, city metropolitan areas kept these records, and most recently the National Weather Service and government and the U.S. Geological Survey. If you look at those records, 130 years here in Iowa City, for example, the clearest thing that shows up statistically is that with respect to precipitation, we're getting more precipitation, but more importantly, we're getting it in intense events, more intense events within the last 100 years. This recent report from the U.S. Climate Change Science Program says there's been a 50% increase in the frequency of days with over 4 inches of rainfall, which was very rare 100 years ago. Now it's reasonably common for us to get 4 inches of rainfall in a single day. In fact, I'm reminded of that week in June of 2008 when the Cedar Basin got something like 4 inches on a Sunday. I think it was June 10th, and followed by about 3 inches the next day or so. And just as the flood, the crest of the flood was coming down the Cedar River, we got about 4 more inches on top of it. And indeed, when you get that much rainfall within a week's or so time, you're going to have difficulty with floods, and we did. There's some indication in the literature, reasonably strong, that we're getting more rainfall globally and nationally and regionally. And more rainfall, maybe 6% more storms per decade based on satellite data. We have a AIRS satellite, an infrared instrument that NASA has, which indicates that we've got more high clouds than we used to have. And it's thought that these higher clouds are responsible for these more intense rainfall events. The literature is a little bit sketchy. There's some studies on both sides, but I would say that the preponderance of evidence is that we are getting more global rainfall, maybe on the order of this particular study in 2005 of about 1.5% more rainfall per decade. Logic and global change models would indicate we should be getting more rainfall, because as the Earth's surface is beginning to warm, of course you've got more evapotranspiration, and that means more moisture in the air, and more moisture in the air means more clouds, and more clouds means more precipitation, and the hydrologic flywheel is beginning to spin faster, and we see that in the data. We're reminded of Cedar Rapids, a flood, their peak discharge during the 2008 flood was more than twice what had ever occurred in that 130-year record. And at Cedar Falls, Waterloo, it was several times more than had ever occurred in that 130-year record. We know from the National Oceanic and Atmospheric Administration in a recent report that it's not unique to our region, but our region is fairly demonstrably higher in severe events. These are the events that occur less than 1% of the time in a year. So intense events, the 1 percentile, greatest precipitation events, and that's up in just 50 years. In the last 50 years, up about 31% for the Midwest. Minnesota, a bit more even than Iowa. And as you may know, the funny weather that's been going on in the Northeast also, maybe 67% increase in these intense precipitation events in the northeastern United States. We have pretty good evidence that from throughout the state of Iowa, for example, that precipitation is greater. I remember growing up as a kid in Davenport, we used to always say, well, we got 32 inches of rain in eastern Iowa. But now it's something more like 36 or 38 inches of rain just in my lifetime. And that may not sound like too much difference, but trust me, it's enough to make a pretty big difference in runoff and the nature of our water resources. You can see it going up here. This is the Cedar Rapids data for the last 110 years or so. Now, if rainfall is up 10 or 20%, as indicated there, runoff is up even more so. And that's because there's some indication in the record as well that not only are we getting these more intense events, but they tend to be more in the spring and the fall, less in the summer. So spring and fall a little bit cooler, less evapotranspiration at that time, and the events tend to, and because they're also extreme events, they tend to run off faster. So they show up as quick flow or runoff without much evapotranspiration. So stream flow is increasing even at a more rapid rate than precipitation. But you know, it's not only about floods and these extreme events, although in our record that's the greatest manifestation that is indicated by whatever is changing our climate. But water availability is a big problem too. This is from a master's student she now works for USGS in the federal building here, Casey Hutchinson. I had her do a very interesting set of maps. This one I thought I would share with you tonight, just on water stress. It's a simplistic view of water stress. It's just the total amount of precipitation that falls on, it's a county type pixel, that falls on the county versus the amount of water that's withdrawn and used by that particular resource. And the orange and the red colors indicate areas that use more water than falls on their footprint. So that would indicate water stress. Now, when she made this map, I thought there were two kind of interesting things about it. One is, first of all, as you maybe would expect, the certain areas in the desert Southwest, Southern California, for example, are using way more water than falls on their footprint. Indeed, if you only allowed the number of people to locate in Southern California based on the water that falls there, you'd have a population of about 1 million. But in Southern California, we have about 20 million people, which can only be served by interbasin transfers. So they're importing water. They're getting it from the Sierra Nevada, from the Owens Valley, and from the Colorado River as well. And that allows there to be, and this is certainly a policy issue, that allows there to be 20 million people in Southern California instead of the 1 million that could survive there based on the rainfall that falls otherwise. But the second and maybe more interesting part of this map, I think, is that water stress isn't just a Southern California problem or a Phoenix and Tucson, Arizona problem. Rather, I don't know if you can see it, but the entire map is pockmarked with areas that are using more water than falls on their footprint. even here in the water-rich Midwest. And more about that later, but we indeed have water stress of several natures that we're going to talk about tonight. And it's really a national problem, not just desert Southwest problem. And certainly it's an international, global, worldwide problem as well. I thought I would use that as an entree to talk about areas that are water stressed and how they might respond to water stress. And I'll briefly use Singapore as a case study. Singapore is a really interesting country from a policy point of view. They have a kind of autocratic government, which you might argue allows them to have such successful water policy as I'll try to describe to you right now. They're a city-state of about 4.5 million people. They have only about 300 square kilometers of land. And about 20 years or so ago, they made a policy decision that they were going to become a leader in conservation of water and a leader in the water industry. They were going to do that for two reasons. One, first of all, they're extremely water short, and they have to import roughly half of their water, even though they catch every drop that falls on their footprint, and they treat it like a treasure, like the precious resource it is. So even though they catch every drop, they still have to import about 50% of their water from Malaysia. So they're water insecure, if you will. So because of their water insecurity, and also because of their unique governmental situation, they chose certain industries that were going to be their lead industries, their showcase industries. We're going to employ their people, provide the economic engine for jobs and for growth in the city-state of Singapore. Water was one of them. Microelectronics was another. Banking and financial was another. They chose about 4 industries. But water was one of them. Very purposely, they said, not only are we going to solve our water availability problem, so many people on such a small island peninsula, but also we're going to create an industry that's a global, worldwide industry that's going to provide for us income for the country. They needed to do that also because they're not only water insecure, they're food insecure. They import 100% of their food. They're energy insecure. They import virtually 99% of all their energy as well. So here's a country which has prospered mightily. Income has grown exponentially in this last 20 years as a result really of policy and governmental decisions. And they have basically solved their water problem. Well, how did they do it? This is kind of the merlion, the emblem of Singapore. It's a fascinating place if you've had a chance to be there. A unique contrast of old and new together. And this is one aspect of solving their water problem. They decided that they were going to, at first, they said desalinate the estuarine and brackish groundwaters. But a funny thing happened to them on their way to desalinating ocean water for their water supply. They found it was much, much cheaper to desalinate and treated industrial and domestic wastewater. So what they did was, not only did they catch every drop of fresh water that fell on the island city-state, but they also discharged nothing. They treated water as a precious resource that it is, and they recycled everything. So they treated all their industrial wastewater and all their domestic, their sewage, their domestic wastewater. And this is a couple of my buddies and me in front of one of their so-called, of course they put a moniker on it that they thought would be attractive and popular. It's called NEWater. And this is the treatment factory for all their domestic, and in this particular plant is mostly industrial wastewater, which is coming in as the source for the water, and some sewage as well. they developed the industry in addition, so they're now among the world's leaders on microfiltration, the first step in the treatment process, with low pressure membranes, ultrafiltration or nano reverse osmosis shown here. They developed this process, and they developed the membrane industry for the high pressure membranes, and ultraviolet disinfection rounds out the process so that you can take this treated sewage and wastewater and you can drink it. And I'm proof positive I'm perfectly natural, as you can see. That you can drink this stuff and be well. And not only that, but in this country we have a problem selling that to the people, that you really can treat domestic sewage and drink it again. We call that direct potable reuse. We have no examples of it in the United States. But we do practice in the United States indirect potable reuse. And actually that's what Singapore is doing at the moment as well, for the most part. But they treated this wastewater to such a high purity that you can drink it, and I am drinking it right here. And they have successfully become an international hydro hub. They're building right now the world's largest, with the technology that they learned by solving their own problem. They've become an international leader. They're building the world's largest desalination plant in Tianjin, China right now. It's just being finished right now as we speak. They just signed, when I was over there, a $5 billion contract for 2 more of the world's largest desalination facilities for Libya. I guess Muammar Gaddafi is okay now. We can do business with him again, or at least they're doing business with Muammar Gaddafi, and sign what will be the world's largest desalination plant. But they themselves found out they did build one desalination plant in Singapore, but they moreover built 5 of these water reuse plants, I would call them, where they're treating wastewater and recycling it. Now, interestingly, they're also clever about the psychology of it. You might ask, well, why do we have no direct potable reuse in this country, and they can do it? Well, it's an interesting story. So this is the NEWater and bottle, and what they chose to do is they take the reused wastewater, the treated wastewater, and they put it in these bottles, and they give it away. So when there's a parade or something like that, or a hot day, you can see the water utilities giving away this bottled water, NEWater, and indeed that is direct potable reuse, much like my drinking it right there. If you drink this, this is the treated wastewater from the plant that I showed you. I asked my cab driver when I was there, I said, well, what do you think about this NEWater? You know, I wanted to see what the locals thought. He said, oh yeah, NEWater, that's great. He said, yeah, we're drinking that for some years now, and it's good for you. And the funny thing is that he's absolutely wrong. He's not drinking NEWater, because in fact what they're doing with the treated wastewater is they're putting it into a reservoir behind a barrage, as they call it. They've dammed off the estuary and created a freshwater reservoir. And what they're actually practicing is what we call indirect potable reuse, because they're taking that wastewater, putting it in the reservoir, and then withdrawing it and retreating it for drinking water. But the people think, 98% of the people think that they are practicing direct potable reuse, and that it's just fine to drink the treated domestic sewage and treated industrial wastewater. So they've already overcome that public acceptability problem that we have, where people won't drink such water unless it's maybe been stored in a reservoir or stored in an underground aquifer for some period of time. And social scientists have done, behavioral scientists have done that research, and it varies a little bit where you are in the country, but maybe they want it to be 6 months or maybe 2 years stored before they're willing to use it as their water supply again. So when Singapore needs to, when they're called on to use direct potable reuse, they're ready to do it. 98% of the people support it. Now, that would be all well and good for us. You know, why can't we practice more indirect potable reuse? We're going to need to treat water, even wastewater, as the resource that it is. It's not a dischargeable throwaway product. Rather, it's a precious resource, and we're going to have to use it. But unfortunately, in our country, we've allowed ourselves, I don't know if you read the New York Times today, Tom Friedman had an interesting column. He starts it out that he's standing in the Los Angeles airport in LAX. And he's looking around and he's going, if you've been to LAX recently, it's kind of a drab place. It might have been swell in the 1960s, but I'll tell you, it's a pretty drab place. And he had just come from China's Beijing or China's Singapore airport, and of course everything is brand spanking new, and all the roads are new, and all the buildings are new, and yes, they're working on their infrastructure as well, and everything is new. And Friedman asked himself, where would you invest if you wanted to place your next factory or your next industry? Where would you invest? In a country that has everything brand spanking new and is investing heavily in their infrastructure, a country like China that has 40% of their stimulus funding money invested in infrastructure? Or would you want to invest in the United States of America, which seems to only be able to patch things, patch the potholes, keep the interstate system under Dwight Davis Eisenhower, which was sold to us as a civil defense measure, after all, to barely keep it going? Which country would you invest in? That's Friedman's column today, if you get a chance. And you raise a good, because our entire infrastructure is like LAX Airport. According to the American Society of Civil Engineers, for drinking water, we can't do what Singapore is doing, not much anyway. We get a D-. For wastewater, we get a D- according to the American Society of Civil Engineers. They claim we've fallen behind in basic infrastructure needs over $2 trillion. I'm changing gears a little bit to talk about water quality and water quantity now. Water quality in the U.S. is threatened, especially by non-point sources, as you may know. Especially how we use the land affects how our water quality is. And globally, I would say it's both point and non-point sources that are threatening water quality. Water quantity, on the other hand, is different depending on where you go. It is a problem of distribution, as is often said, but the distribution is changing due to climate change. Generally, if you look worldwide, just at the data, not the models, if you look worldwide, humid areas like Iowa are getting wetter, and arid areas like New Mexico and Arizona are getting drier. Worldwide, as a generality, that's not too bad. That's what's going on. Not model prediction, just what's going on right now with the record that we have. So quantity, because we use such a great percentage of the fresh water that passes by us and is stored in our lakes, already by one recollection, by one study, maybe 50% of all the available fresh water is being used, we can anticipate problems in the future, especially in light of the last point, our tendency to form mega cities. Everybody wants to live on the edge. In this country, 54% of us are now living in coastal counties, and it's rapidly increasing. We're going to be the last ones in Iowa. I'm here to tell you, and I hope somebody turns off the lights when they leave, because everybody wants to live on the edge. Worldwide, mega cities are forming, more than 10 million each on the edge of the continents, and that's where the water problems are especially severe. On the plus side, our water withdrawals, we do show signs of water conservation in this country. Our water withdrawals have not increased for over 20, 30 years. We haven't seen a significant increase in water withdrawals. That's a good thing. Another good thing, I suppose you could argue, is that dams have kind of stopped being built. So if you're worried about the fisheries and the ecology ecological habitat, which is often destroyed by dams, we're not building any more dams. In fact, we're tearing a few smaller dams down in order to try to restore habitat for fisheries. Regarding the point and non-point sources and their effects on ecosystems and inland waters, if you were to be hard-pressed to say, how are we doing? What's the nation's report card with respect to water quality? I would have to say that it hasn't improved much since the 1990s or so. I'll be curious, Mary, what you think. I think we had a big improvement in the 1970s, 80s, or around there, but it was largely because we also made a big investment. We talked about infrastructure already and how that links up to water. We made an investment of about $100 billion in the public sector alone from the Clean Water Act of 1972. So we paid municipalities, the federal government paid municipalities to improve their wastewater treatment and to decrease their emissions to surface waters, and it improved water quality. So we invested a lot and we got something for it. But that has sort of plateaued now, and the remainder of our problems seems to be, for the most part, non-point source issues. And those are listed here. And they don't seem to be getting better. In fact, you can make a pretty strong argument that at least on the coasts, for the reasons I mentioned earlier, they're getting worse. You know, water quality is kind of, and ecosystems, aquatic ecosystems are kind of sensitive. They're very sensitive to how we use the land. And urban sprawl, peri-urban, I should say, the kind of thing like we get in the corridor between Iowa City and North Liberty, this affects water quality a great deal. And in fact, the literature indicates that only a 5 or a 10% change in the footprint of the watershed, say a 5% change in impervious cover, so asphalt parking lots, strip malls, new highways, just a 5% change in the footprint already begins to change, to deteriorate the quality of the urban streams and ecosystems. So very, very sensitive to this sprawl that we are now famous for. And of course, since pre-settlement times, you may know that I have a friend who has a farm just south of here. It's a century farm, but it's almost now coming on. It's a good old century farm. It was deeded to his family in 1837. The land. I think that's the oldest century farm that I've seen anyway. That's about the time this place began to be settled. And of course, you know the story. We drained all the wetlands. About 95% of the wetlands have been drained for agriculture for the most part. We plowed up all the prairies. About 99% of all the prairies have been plowed. And we cut down most of the forest, about 75% of the forest, which were largely in the bottomlands along the streams. And we did all that for the sake of development. And of course, I just asked my students last hour, I teach a class called Sustainable Systems, I asked them, what did we get for that? And they answered correctly. Well, what we got was an agricultural-based economy. And that's what we got. And then, of course, we asked the question, well, what ecosystem services have been lost from the wetlands and from the prairies? And they were quick to point out what has been lost as well. But you can't monetize that very well, the ecosystem services that have been lost versus the agricultural productivity. Indeed, you could say our entire economy in state Iowa has developed as a result of draining those wetlands. So we got something for it, but we paid the cost. And this is our land use map today. The yellow area indicates intensive agriculture, and you can see that we're indeed very intensively agriculture in this Iowa area. In fact, the Upper Mississippi River Basin has changed mightily since my friend's farm was founded in 1837. We have sediment shortage in New Orleans, but we have a sediment excess still in the Upper Mississippi River Basin. It threatens a $1.2 billion a year recreation industry, a $6.6 billion a year tourism industry. I didn't know we had such great tourism industry, but it must be true. And it affects the nutrients draining to the Gulf of Mexico. We think that we're between 30 and 35% of all the nutrients going down to cause problems in the Gulf of Mexico. We spend about $100 million a year on dredging costs for the Upper Mississippi River alone. And climate change is changing considerably the runoff and water resources patterns such that levees and dikes need to be reconsidered and redesigned. I'm told that Cedar Rapids, as a result of the 2008 flood, plan to have higher flood walls installed in Cedar Rapids. We're considering similar here at the University of Iowa, and of course the net effect of that is to send the water downstream more rapidly to the poor souls who lie below us in the watershed. So for good or for bad, we're kind of at the epicenter of a nutrient problem, a nutrient runoff and export problem. Nathan, this is your wonderful pool 16, and you can see that we're exporting about 1,000, oh, I'm sorry, I left off the units. I think it's 1,000 kilograms per hectare per year of nitrogen, which is over $1,000. Well, now it's about $600 a ton, the nitrogen that we're putting on. So we're literally exporting a couple $1 billion of fertilizer down the Mississippi River. The total maximum daily load is a national program. Maybe Mary Skopek will talk about it. For improving our water quality. We have about 20,000 impaired waters in the U.S. It's to remedy the impaired waters of our nation. And these are some of the causes of those. We'll look more specifically at Iowa. More recently, invasive species have become an important part of the story, and this is the zebra mussels, which have taken over the Upper Mississippi River valley. Our Iowa rivers and lakes, you know, Minnesotans like to brag that they're the land of 10,000 lakes, and we're the land of, I don't know, 9 lakes or something like that. Natural lakes, we have a few reservoirs also, and some natural lakes up here, especially in north central Iowa, and some quite good quality ones still in the Okoboji and Spirit Lake, the so-called Iowa Great Lakes region. But they are impaired. The most current counting, I think, Mary, was in 2008. The numbers keep going up as we get more and more monitoring data, and as we look more closely, we have about 439 waters, rivers, lakes, and reservoirs out of 1,100 that have been looked at. So maybe 40% of our ecosystems that have been investigated are impaired, meaning they don't meet their designated uses as they should. And that means we need a TMDL, a total maximum daily load, which is basically a plan for how to recover those streams, lakes, and ecosystems. This is an older picture of some of our impaired waters in Iowa. The red dots indicate impairment of a lake or a stream. And the more recent count is shown here, just to give you some idea. By Iowa Department of Natural Resource reckoning, 357 streams are involved, and bacteria is the major cause, but followed very closely by our ecologists at DNR do reconnaissance on the streams and lakes. They look for what's called the fish IBI and the macroinvertebrate IBI, the Integrated Biological Integrity Index, and that's when they're the rock turners, you know, who look for the invertebrates under the rocks, the mayfly, the caddisfly, the stonefly larvae. And if the larvae aren't there and they should be there, that's an indicator of good ecosystem habitat that has failed. And if the fish that should be there are not there, that's an indication that the aquatic habitat isn't what it should be. Some of the others are shown here, and we can talk about them as well. For the lakes and reservoirs, it mostly has to do with too much algae, which has to do with too much nutrients. And the algae actually cause the pH to fluctuate. So when the algae produce oxygen during the daytime, they take carbon dioxide out of the water at that time and turn it into sugars, and that causes the pH to go quite high. And that's impairment in some of our lakes, algae itself, algae causing turbidity, and silt erosion causing turbidity, and so on and so forth. Just a picture of some of the lakes that have troubles with phosphorus in Iowa. So if I were to summarize, I'd say Iowa's water quality also is no longer improving, mostly due to Nonpoint sources. We have pretty good evidence that some rivers, especially the Raccoon and the Des Moines, are still increasing in nitrate concentrations. Nitrogen fertilizers are applied at record levels, but record amounts of nitrogen are being taken off with the crop. We have record yields also. There's some indication in the data that conservation tillage, when I was a boy growing up in Davenport and we'd drive through the countryside, often in the wintertime you'd see black soil, deep plowed, so-called moldboard plowed, laid open for wind and water runoff and erosion. We don't do that anymore. In fact, a lot of farmers plant the next crop right through the residue of the previous crop, so-called no-till agriculture. And there's some indication in the data that turbidity and total suspended solids are decreasing, total phosphorus also decreasing as a result of this conservation tillage. So there's some good news. On the negative side also, we still have problems with the performance of our concentrated animal feeding operations, and maybe we'll talk about that later. They're mostly concentrated. The concentrated animal feeding operations are mostly hogs and mostly concentrated in the north central, northwest part of the country. And so I would say the animals haven't really increased much. So I would say it's mostly a problem of the density of animals in such a small facility, and what to do with all the manure from those animals. They are regulated. They have manure management permits, and those permits are supposed to be based on how much nutrients you can put on the land. But of course the problem comes when you may be a good citizen as an agricultural producer and putting just the right amount on, but if a rain comes right after you apply, it's going to run off inevitably and